Hello and welcome to everyone. Thank you for joining us on this session today. Hope you're having a great time here at the AWS Summit, learning about the new offerings from AWS and our partners, and enjoying the conversations. It's been truly great for me meeting partners and customers in person after a long time and learning about their new use cases and requirements. And today we've got a very exciting use case to talk about. We're going to talk about how the US Navy used AWS Snowball Edge and deployed them on the Navy ships to run compute applications. I'm Ramesh Kumar. I'm the Senior Manager of Product Management in the AWS Snow Family of Services. And joining me here today is Fernando Cancel. He's coming up on stage. He's the lead architect and engineer for Duchancel Consulting. And we also have Rafi Doyle, who's the lead program engineer for the US Navy on the UNACORN project. Unfortunately, Rafi was not able to travel and be with us here in person, but we'll hear about her great work. Fernando's going to talk about that. So just a little bit on the agenda. We'll start out with, I'll provide you an overview of the continuum of AWS services from the cloud to the edge, and talk about how the AWS Snow Family, Snowball Edge, Snow Cone, how you can use them to run your compute applications in the rugged, mobile, disconnected, and tactical edge locations. And then Fernando's going to come back up on stage and talk about this really wonderful use case with the US Navy. You wouldn't want to miss that. And then I'll come back on the stage towards the end, talk about the benefits of AWS Snowball Edge and Snow Cone and how customers can use them to run their compute applications at the edge. And we'll leave some time at the very end for any questions that you may have for us. So I'll jump straight in. So I'll provide you an overview of the continuum of AWS services from the edge to the cloud. Starting with the cloud at the very right of the slide, when you run your applications in the cloud, you get all the benefit of all the 200+ services, online monitoring, management, resiliency, reliability that AWS Cloud provides. But as you very well know, not all the applications can run in the cloud. There are many applications, many emerging use cases where you need to run the compute and analytics, and you need to store data right where the data is being created or generated. And let's talk about how AWS can help you do that. As you move towards the left on the slide, we are effectively extending AWS infrastructure and services closer to the edge where the customers are. You see local zones, which are deployed in metropolitan areas and other IT centers. And then you have Outposts Rack, which is an extension of AWS infrastructure and services right to your on-premises location. If you move further to the left on the slide, you'll come to the rugged, mobile, disconnected edge, harsh environments, the tactical edge. And this is where you can use the Snow family of services, AWS Snowball Edge and AWS Snow Cone. You can deploy these devices, hardware, running AWS services in the rugged mobile edge locations for long periods of time, run your applications completely independent or disconnected from AWS. And when you're ready to transfer data, you can communicate back to AWS Cloud to do bidirectional data transfers, and you can update resources. So software, AWS services, your armies, VMs, container applications on the Snow devices. As you move further to the left, you'll see specialized services, AWS Wavelength, which is deployed in telco networks, AWS RoboMaker and Sitewise Edge, which are suitable for factory and industrial applications. And then at the very far left of the slide, you'll see our IoT services. Greengrass, and then on Greengrass you can run analytics with Kinesis video streams. You can run ML inference at the edge with SageMaker Neo. So take your ML models that you trained in the cloud on SageMaker and run it at the edge on SageMaker Neo. Now, all those services at the left of the slide here run on Snow Family devices. So you can run Greengrass for IoT Hub applications on the Snow devices. You can run Lambda functions on the Snow devices. You can do ML inferencing on SageMaker Neo. You can do data analytics and video analytics with Kinesis video streams. So again, diving a little bit deeper into the Snow family itself, there are two main services, AWS Snowball Edge and AWS Snow Cone. Within these services, you'll find many different orderable configurations with more compute, less compute, different types of storage, different amount of storage, NVMe storage, different types of capabilities, radio capabilities that are integrated into the Snow family devices. And effectively, what the Snow family devices do, Snowball Edge and Snow Cone, they provide a deployment platform for your AWS services, applications, functions at the remote edge, rugged, mobile, disconnected, and tactical edge. So think about you can deploy Snowball Edge and Snow Cone in the location where the data is being generated or created, collected from sensors, from drones, from video cameras. You can store the data locally on the Snow devices. You can use it as an IoT hub. You can do image analysis. You can do video and data analytics. You can run ML inferencing. So basically, you can use the Snow devices to gain real-time insights, make those real-time decisions and AI-based decisions at the rugged edge. And as I mentioned before, your applications and operations that you run on the Snow devices, they can run independent of AWS or disconnected from AWS for long periods of time. When you're ready to send the data back to AWS Cloud, you can use AWS Data Sync for bidirectional data transfer. And you can set up your communication and networking mechanisms, SD-WAN, 4G, 5G, fiber, backhaul, satellite, to bring that data back to AWS, or update the resources on the Snow devices that may be deployed in the field for long periods of time. Update the Snow software, update your certs, update AWS services, your VMs, your container applications running on those Snow devices at the edge. All right, so Nando, please come up on stage, and I think the audience is waiting to hear from you.
Thanks, Ramesh. Good morning, Fernando Cancel. I'm the lead architect under Navy Project Unicorn. I'll give the presentation on how we deployed rapid capability to the Navy Edge, which essentially means ships. I work for Ms. Rafi Doyle. She was not able to travel, so I'll be representing Team Unicorn and specifically the COVID-19 tracking system we put together. So the project Unicorn, and you'll see the C19 tracker as an acronym. Unicorn stands for Universal Naval AI Core Environment. We took some liberties with that acronym to generate the name. It's a project that was sanctioned under the Digital Warfare Office to do transformational technology injections into the fleet. We're still part of that team. It's our third year on this project, and the COVID-19 tracker was a special, a one-off that we did, and I'll explain that. Our main success was to quickly deploy a COVID-19 tracking capability to U.S. force level ships, and I'll get into that. And more importantly, we were able to rep sync data off the U.S. ships at sea, or underway, like we say in the Navy, back to the U.S. GovCloud to then allow epidemiologists and data scientists to take a look at the data for the COVID-19 pandemic as it was surging through the fleet. So I'll start with the bluff. We essentially migrated a cloud-based system. If you can go back in time to May of 2019, when the pandemic was starting to take hold, the USS Theodore Roosevelt became sick, and we pulled her into Guam. I don't know if you recall. The whole crew had to be quarantined, And out of that, Defense Digital Service created a tracking system completely on AWS IL4, not GovCloud, to track the crew. The essential of that was the crew got used to self-reporting their symptoms, including temperatures and feelings on a survey. And I'm stealing my own thunder, but you'll see why. They got used to doing that in the easiest way possible, which were personal devices or via the web at the hotels in Guam that they were being quarantined at and somewhere on the ship. That drove our architecture and the requirement to allow the crew to self-report instead of having to go to like a single location or talk to the same medical officer all the time, which would spread. At that point, we weren't really sure of the spread or the vectors. So that's why we architected the way the system that looks today and finally got deployed. The little screenshot there we're very proud of were actual data syncs from the 8 different force level ships back to GovCloud, and then we would provide access to the S3 bucket to Navy Health and DDS analysts. And we got to talking to a lot of different medical and health professionals, but they were getting the data off the ships near real time, and we'll talk about that, because that's a loaded term in the Navy. We leveraged the baked-in security, the ruggedness of the Snowball, the ability to store all the data we would ever need, and then those 3 different local area technologies, their routers, Wi-Fi, and WAN, wide area network, was the 3 requested courses of actions that we needed to provide PAC Fleet to track the ship's force or the sailors. I mentioned that we had gotten the call in May, and we got that call from PAC Fleet, and it was Admiral Aquilino, who was the PAC Fleet commander, saw the capability on the web. We got a phone call, can we deploy this to the ships, and how quickly? And then we got into the pretty interesting situation where Defense Digital built the tracking tool completely on the cloud, and we needed to deploy it completely to the edge. So we had to transform or convert some of the systems that are running on the cloud natively with all those APIs and robust connectivity to be able to run remotely on Snowball. That's what these 2 architectures show. We ended up containerizing the applications. We ended up providing a rep sync mechanism back to the cloud using Niagara files, NiFi, and we were able to do that in 5 weeks, with week 5 being my first deployment to the USS Nimitz, which we're very proud of. For some of you engineers, this is what it looked like. I talked about the 3 methods of access. Typically, on a USS, United States ship, you're not going to be allowed to turn on your Wi-Fi device and connect to anything. We had some dispensations to do that when the ship needed to do the survey and get all the data into the COVID-19 tracker. Wi-Fi was enabled on cell phones, and we deployed a flyaway kit so they can connect to the Snowball. All those applications that were previously on the cloud were now running natively on the Snowball, and the crew was either using their cell phones or using ship's computers or Wi-Fiing on a laptop direct to the server. We were able to create security boundaries to allow that to happen, and we also proved to Navy security that the only data coming off the ship was the data we wanted to come off, and sending it straight to an endpoint in an S3 bucket in GovCloud. This received an IATT in record time also. Obviously, it was urgent times to get this done, but it was an end-to-end deployment of capability at sea, connecting and syncing data back to the cloud. Basis of issue, some of us went to most of these ships, and we ended up, so this slide is missing, we got a different slide. We ended up deploying 8 kits. The last ship was the Theodore Roosevelt after she came back from deployment, so I'll skip ahead. It was all force level ships and big deck gators, so the amphibious ships. Those are some of them. The tool that the crew would browse in looked like this. It was essentially, and we all have lived COVID now for a couple of years, but it was essentially a self-reporting tool that would allow doctors to interview the crew, and the crew would be able to put in their symptoms and their temperatures remotely, and in their own spaces, which was pretty powerful at keeping the quarantine in place. So, Ramesh, do you want to go back to key benefits, or I can talk about them too, because we lived them. So, for us, 5 weeks deploying a pretty significant software system to a US ship is unheard of. Normally it takes years to go through all the wickets. We were able to leverage the security, the TPM security that Snowball provides, its ruggedness, and we were able to leverage both the storage and the compute on the devices to deploy, collect the data, and then by running a pretty straightforward NiFi workflow, we're able to sync data back in a stateless fashion. Whenever a US Navy ship turns, you lose bandwidth. I'll keep it simple like that. But essentially, we're just at a presentation where the Army guys were complaining about their comms, and I'm like, nah, you guys got a lot of comms. It's harder when you're turning all the time, but we were able to live within that communications bandwidth budget and send data back almost continuously. We were seeing rep syncs to the minute from data off the surveys on the ship, which is pretty cool. And we didn't get any priority traffic because that bandwidth on those ships is gold and it's very tightly controlled. So we just lived within the windows that we were given, and the system was able to send data back. Secure, one of the things we did for security was we pointed to the security packages for the Snow platform and ended up doing that in EMAS, which is the Navy's tracker for security, and pointed to previous controls, previous accreditations to get that rapid IATT. We were technically always disconnected. If you could picture being on a ship as a connected system, but the ship is not connected to any network all the time. So we were able to do compatibility by using some of the Snowball APIs that were syncing back to S3 on the cloud. So scalable, we only needed one Snowball, by the way, so we didn't need a cluster. And that's it. I think I jumped on your slide, but.
Thanks, Nando, and I'll just, thank you, and I'll just add to that. So when you look at the services that we host on the Snow devices, Snowball Edge and Snowcone, so when you're looking for compute, we've got EC2 compatible APIs, we have EKS distro, which to what Nando was mentioning, you can develop your application, test it, validate it in the AWS cloud, running on EC2 as a VM or as a container application on EKS. And when you're ready to deploy it at the edge, you can deploy it on Snowball Edge or Snowcone. Now, what you'll see is that we don't support the entire 100% of the APIs of those services on the cloud, but for the subset of the APIs we do support, they are the same, which means it'll make it very easy for you to take your application developed in AWS, in EC2 or EKS, and deploy it in the edge. And we are expanding on those list of services. So we launched recently Greengrass version 2, IoT Greengrass version 2 for IoT applications, Lambda functions, so for serverless compute, KVS, Kinesis Video Stream, SageMaker Neo. All these services are hosted on Snowball Edge and Snowcone, which means you can take your machine learning trained model of machine learning in the AWS cloud on SageMaker and run it on SageMaker Neo at the edge for ML inference. For storage, we've got EBS compatible API, S3 compatible API, so you can store your data locally. And then we're continuing to expand on that. We get feedback for additional AI ML services, things like recognition or transcribe or translate and comprehend. And we're taking in your feedback. When we say these AWS services run on the Snow device, both the agent and the control plane of the services run on Snowball Edge or Snowcone. That's what allows you to run these your applications, your operations, your functions on the Snow device, independent of AWS, locally managed for long periods of time. And Nando hit upon scalability. We're seeing more and more requests from customers to run a fleet of Snow devices to run their operation. It could be a multi-node Snowball Edge compute and storage deployment in one location, or it could be thousands of snow cone devices deployed in geo-dispersed locations. You can literally carry a snow cone on the warfighter's backpack, right? So you can think about how that dispersed large fleet of snow devices can be deployed. And our customers want to locally and remotely monitor and manage these devices. If you've got thousands of Snowball Edge and snow cone devices deployed, either in one location or multiple locations, how can you monitor and manage these devices? So those are capabilities we are bringing out to you. You can update the resources on the Snow devices, so either the AWS services, Snow software, your own applications, that maybe you've updated your machine learning model in the cloud, or you've updated your VM or container application in the cloud, and you want to now update it on the Snowball and snow cone devices deployed at the edge. So you can do that as well. So with that, we'll turn it over to any questions that you may have. I think there's microphones set up in the aisles if you want to come up and ask your question to either Nando or myself.
So do you have any of the of those COVID trackers currently installed on board ships? And what's the long-term, I guess, disconnected?
No, so good question. Is that it? Do you have anything else? So we were rapid deployment of capability in RDC, and we deinstalled earlier this year as the pandemic was tapering. And Defense Digital and that original platform that was on the cloud was kept alive, but we deinstalled February, March. So we truly were rapid, surge it, track it, and then pull it off. So we're hoping this pandemic is not a permanent thing. So that was the other, we got an IATT, and we very specifically said it was a limited time to collect the data for epidemiology reasons. So it's not a permanent POR deployment. So we pulled them. I think we pulled the last kit off in March. So that came off Reagan. So all the kits are back home.
Yeah. From a cybersecurity perspective, did you see any non-shipboard personnel trying to access and inject any sort of information, and how was that managed?
No, so security boundaries and least privilege, and I went really fast through the architecture and the applications and the security groups that we implemented, but essentially least trust between every stepping stone in that browser. So that browser would only let you do one thing on this Tomcat server, which would let you do only one thing on the database, and that database was being dropped on S3, which could only send certain data off S3, off secure crypto transport back to the cloud. And that was the cloud endpoint. So every one of those steps, none of those systems or resources could do anything more than what it was supposed to. So we proved to the NAO, the Navy accreditor, that was very secure. So we had there was no issues with injects. And if you architect that way, it's pretty easy not to allow any other nefarious behavior. But again, all we were enabling was collection of COVID data. So we weren't opening up a browser on a ship to let the crew surf out, which is a much harder problem. So, but that least trust in every step of the food chain. And we use containers, and some of the security container guidance that was out last year was implemented. So it worked pretty good, and it's pretty tight. So.
Thank you.
Yes, sir.
Hi. So do you guys have the capacity to pull that off for a long-haul program?
We did. So part of the prototyping work we do is transitioning to programs of record. So the capability of Snowball at the tactical edge and U.S. Navy ships was not delivered, but presented to our program of record offices, which some of the Navy offices are using. We're out of San Diego, PLC4I and NAVWAR. Some of the programs of record are starting to see and use the capability. So yes, sir.
Yeah. So I work for one of those programs, but what do you think your cost per hull was for this project?
Cost per hull. Can you define haul? Do you mean like per
Hull
snowball?
A hull number. Per ship.
Oh, hull, sorry. I thought you meant HAUL, hauling data. That's a pretty good question. Usually we'd use the calculator. So Amazon has a pricing sheet for snowballs longer than the normal use, and we were well within that. So I think our total cost for the fleet was $92,000 for the snowballs. Correct, for the 8 kits. We obviously have to buy some other parts of the kits, but that's a snapshot. I'm the lead architect, so I know the number. The specific breakout is, a little bit smaller.
How many ships?
8.
8 ships.
Yeah, and what I'll say on pricing is what Nando referred to as our public pricing. Clearly that's, if there's higher volume type deployments, reach out to AWS through your sales teams or partners, and we can talk about, higher volume pricing.
Yeah, and I'm a big believer in the model of lease it, don't buy it. And then we were off the GovCloud schedule. So if you go to a commercial region and see the pricing, that's not the one to use.
Yeah.
But we were landing data on GovCloud, which was better than Defense Digital, who was doing IL4, because we have more controls than GovCloud for government-owned data, ITAR and others. But essentially, it's maybe a 10% more on GovCloud. But I mean, I'm still talking $92K for an 8-ship deployment as far as the infrastructure part. So.
Were these all flat tops?
Sorry?
Were these all carriers?
3 CVNs, 3 LPDs, 2 LHAs. Apologies, that slide wasn't updated, but so they were mostly flat, but there's a couple pointy nose LPDs in there. So.
No DDGs, no.
No, not unit level. That was a decision that was made by Pac Fleet. Those ships were small enough that essentially the independent duty corpsman could track the 140 people on a DDG. While you can't track 6,000 people with, the 80-man staff on a carrier.
Right. But for my purposes, we're looking at all 300.
Okay. Yeah. No. Absolutely. So it's it's a different business model. Lease it. No, don't buy it.
Yeah, and it's just to build on what Nando mentioned, so the pricing is not, you don't purchase the snowball and snow cone, it's a lease price, and with the lease price you get the hardware, you get the snow software, you get the AWS services running on them, and you get support on them. And since AWS owns the devices, if something goes wrong, they get damaged, that's going to be on us, and we'll replace the devices, right? So that's kind of the benefit of this lease model, if you will, or subscription model versus you having to purchase these devices. And for any volume-based deployment, just reach out to us for pricing.
Any other questions?
If there's no other questions, let's give our speakers a round of applause.
Thank you.
Thank you.